on the EXO 200, successful EXO 200, and is projecting to be sensitive down to 10 to 28 years of a half-life, so it's really, really rare. And now we're developing a lot of deep learning tools, so that will be validating EXO 200 and then used in EXO. And then beyond EXO, we already have some research going, such as discrimination, improved discrimination of signal backgrounds, and ways to produce that much xenon to be of the order of tens of tones for the search. Thank you.
Hello. Thank you very much, Caio, for this very interesting talk. I am really, really, really happy to have heard about this, because I always wanted to see the gritty details on how to run these underground experiments. Mm-hmm. So let's take questions from the audience.
I have a question about cryogenics.
Yes.
Cool this down to below 1 degree Kelvin?
No, sorry. It's 100 degrees Celsius, so it's 200.
I saw a plot where you have a 0.1 Kelvin.
Yeah, that's, well.
0.7 is this one. The right most.
Yeah, sorry, there is a star.
What's the star?
It's an effective temperature. That then there is this, so there's this Leonard-Jones coefficients that brings the boiling points to very similar scale here. Sorry, it's just a star. So it is a correct temperature.
So you don't need any cryogenics.
It is, the cryogenic here is meaning that it is in liquid phase, these noble gases. So it's always of the order between 80 degrees to 120 degrees. Minus 80 to, no, sorry, 80 kelvins, right, to 100 kelvins.
So what do you use, liquid nitrogen?
No, we have this fridge. It does, yeah, there's this thing black on the top. It can cool down about to 70s. It can't go beyond that, because I really wanted to do neon, but neon requires even cooler temperatures to be at the boiling points. But that fridge, or cryo cooler, that doesn't have the power to bring it below. So we run argon. Argon is the coldest one we run here, and we run this between 80 and 85 kelvins. Yeah, but it doesn't go to 1 Kelvin. Yes, that is very difficult. Yes, yes.
Then the other question is, how does it compare to other experiments on the generalized double beta decay, like Genius, for instance, right?
Legend.
There's something called Genius, or was it? Or?
No, so there was Gerda.
Gerda.
Yeah, I should put a plot on my background or my backup slides. Yeah, no, I mean, okay. So what I would say is EXO 200 stopped data taking in 2019. So we're not leading anymore we led just at one point, and then the last result at 5, where is this? This last result at 5/10/25, that was very competitive, but it was still below the leading, which was 1026, 1.1 times 1026. No, that was Kamlan-Zen, which was also xenon. Gerda is germanium. They have higher half-lives, but their mass conversion is worse. Like their nuclear matrix elements doesn't convert to the same mass limits, so they lose on these, but they are of the order 1026, 1027 too. Well, Gerda was 1026. Legend, they are now finishing building Legend 100, which is 100 kilograms of germanium crystal. But they haven't, I don't think they started running yet. And then they...
That's Gran Sasso?
Yeah, that I believe is in Gran Sasso, yeah. And then they have this proposed, like we have proposed Nexo, they have Legend 1000. Kamlan-Zen doesn't have much beyond what they have now, because their technology won't go to tones like ours. But Legend has 1000, and it's very competitive in Nexo. They aren't different. In the end, they won't be different than that. It's just a different technology. And then for a while, we were competing with DOE and other fund agencies until last year when they have a review. It turned out that Legend won in every point, but they don't recommend Legend to be built alone. They want at least 2 technologies to be built, and they are planning 3, tellurium-130 will be copied. It's not as sensitive. Legend and Nexo. So DOE said they want both to be built, one in North America, one in Europe, but they don't have money to fund any of them. So that's where the status is now. So now what we are doing.
That was the P5?
No, I'm not sure the name, yeah. But was a review specifically for neutrinos double beta decay experiments in July. And yeah, now so what both collaborations are doing now is we're looking into international collaborations that could maybe support more and then bring another. So what we requested from DOE was essentially $300 million, exactly like Legends, like about same cost. And they don't really have that much money. So what they're asking is to see what are countries that can fund. So Canada is entering with some amount, and they're asking more for Canada, China, and see if we can match some amount that they can then fund. So this is where this is going. But DOE has this process of evolution of experiments. Like there's this CD0, CD1. So now both Legends and Nexo are in CD1. They have funds, right, to still fund R&D, but it's not guaranteed that they will be building it. Yeah, so that's where they are. Mm-hmm.
Further questions to Caio? Okay, I have one question as well. But so I work in the LHC and particularly work in dark matter. One thing that drew my attention was the fact that you speak about liquid argon only. Why? Yeah, no, xenon, sorry.
Yeah.
Liquid xenon. Why liquid only? Why not dual phase?
Yeah, no, that's a good question. So the technology we have here, this TPC is liquid only, because it works to this precision of millimeters, right? But that's exactly what we're trying in Carleton. This is dual phase, right? So
this is dual phase.
yeah.
Okay.
So, but I mean, Nexo is designed to reach the sensitivity we'll have with single phase to the millimeter precision, right, or millimeter resolution. But if you go dual phase, we believe you can achieve tens of microns if you install SIPMs, because SIPMs has a bunch of pixels, right? And then it has very fine electronic resolution. So we're testing this, but it can't go to Nexo because Nexo is, to request funds, you have to be settled in this technology. And it's okay. I mean, if you were to apply this in Nexo, we maybe would go from, like, today is 1.35, 10 to 28. It will go from 1.35 to 1.7. It wouldn't go substantially different. But no, in the future, it is a possibility, yes. It's
Understood.
still open. But yeah, it's a good question because it does bring more spatial resolution.
Okay. Questions to Caio? Dou-lhe uma, dou-lhe duas. Vendido. Thank you very much,
Yes,
Caio,
thank you.
for your talk. Since